Okay, so far we have a long discussion about this thing, which is the condition 1 of phase 1, where we assume that our image is only affected with noise only. So I think for in the meantime, let's call it as a condition, because I'm thinking about it's better to call that condition 1, condition 2 and condition 3 rather than phase 1, phase 2 and phase 3, because we talking about these three cases is actually, these three thing is actually is a separate cases. It's not related between one to another. Okay, it's not uh, you know phase 1 first, and then second we have phase 2, and third we have phase 3. No, it's better to call this one condition 1, condition 2 and condition 3. I think that word is better to represent this kind of things. Okay, because actually it's a different cases. Okay, we talk about the different cases. One, and the first one we talk about the image only affected with noise only, and then in this video lecture we talk about the condition 2, which is the image is affected with blurring function, or what we call, okay, you can call blurring function or degradation function. Okay, it's referred to the same things. Okay, if we assume that our image is free from the noise and only affected with blurring function, then this is how it's look like. Okay, but before that I want to do some summarization on this one. Okay, let me share with you some slide here. Later I will try to provide you with this slide. Okay, this is some summarization. Actually this slide should be shown to you right after I end up all this topic, which is chapter 5. Okay, but let's discuss earlier, so then you can see what are the summarization that what we have learned in so far in chapter 5. Okay, as you can see here, this is our degradation model or restoration model. Okay, this one should be the condition number 3, which is the last one. Okay, when we assume our image is affected with both noise and blurring function or degradation function. Okay, and then in condition 1, this is what we do. Okay, we discuss about where our image is only affected with some noise. Okay, and your hardware is actually free from blurring factor there. Okay, so that is why the block diagram look like this. And then we have a very long discussion about talking about this noise. Okay, because this noise is random, then it's impossible for you to just get this image G to get this image G and to get this image F. Then you just you cannot simply take this image G and minus the noise. Okay, because of that randomness characteristic. Okay, and then since we know that that is the fact, our noise is random signal, then one way to represent our noise is through PDF. And then how to model the PDF? Of course, you need to take a plane surface here, to take image of plane surface. And another things I forget to mention in my video lecture, but that this thing is discussed in your slide, is that if impossible for you to take the plane image, for example, it's hard for you to access your hardware, or it's hard for you to access your camera. For example, you for example, let's say your camera is already old and is not working anymore, and actually you want to investigate what actually what are the factor that contribute to the degradation of the image that taken by using that camera. Okay, one way you can do, if your camera is not working anymore and then you cannot access your camera, is you can take any pictures, old picture that taken by using that camera, for example this one, and then what you can do, just crop any background or any surface in you select any image that consists of plane surface, and then you just crop, and then you will proceed with the same thing, meaning that once you get the plane image, the crop the small portion of plane surface, then you generate the histogram, and again and that is how you perform. Then you generate histogram. And then the reason why we take the plane surface to investigate the noise is that we know that theoretically that if our plane image is free from the noise, then okay, this one is if our plane surface here is our f, which is free from noise, then if we generate the histogram, you only can see a single bar there. But that is impossible to be happen, because in practical, when you generate the plane surface that from the image that affected with noise, then you can have some sort of histogram, and of course from that histogram then you can identify what type of noise that affected that image. Okay, for example, this one, okay, this one is what type of noise that affected our image. Okay, this one is not bell shape. Okay, bell shape is, if you're talking about bell shape, that is Gaussian noise. This one is a uniform noise. Okay, it's in shape of square or rectangle. Okay, you can refer to the slide. Actually, this is a uniform noise. Okay, so then after that's all for this condition 1, where after you investigate the noise and you extract all the parameters related to that noise, then you can choose what are the suitable filter, that whether it belong to mean family filter or is it belong to statistical order filter, to be used in this restoration filter blocks, okay, as a filter to obtain your f hat. Okay, so in this video lecture, we're going to talk about condition number 2. Okay, condition number 2, we assume there's no noise, meaning that your image is free from noise, but it's affected with degradation function or blurring function here. Okay, the only that affected your image G is this one, factor from the blur, where it's actually can be modeled as a degradation function, or it also known as a blurring function. Okay, in your slide, in the slide notes there, most of the time they are using the word blurring function. Okay, blurring function and degradation function is the same thing, which is referred to this block. Okay, so now the block is look like this, and then of course if you try to write the equation now, this is the equation to represent your gxy in spatial domain, which is the combination, which is the convolution between the degradation function and image f over here. And this is where you condition number 2 as well as condition number 3, most of the time we will process or compute the estimate this thing, or do the modeling in frequency domain. So that's why, like I mentioned previously, that's why you need to have some knowledge in chapter 4, because this is where most of the cases we handle in frequency domain. So that's why from here, if you write the frequency domain, it's the convolution will become the multiplication. Okay, seems like the previous cases, okay, the first question there, if you remember, we want to model the, okay, this one we want to model the noise, okay, that affected our G. But in condition 2, okay, this one, now the condition 1, since this image is free from the noise, then the image is only affected with this degradation function. Then now our objective in this degradation mechanism is that, or in this degradation block here, we want to model or estimate our H there. Okay, because once we manage to estimate our S, then we know how to apply the restoration process to get our F hat, which is for the purpose of the same thing like we had discussed earlier, where we want to have our F hat as close as our F. So now in these cases, in this condition 2, then since we have image that affected with degradation function, now our objective, we want to estimate or model this H. Okay, there's a three. Okay, how to model or estimate this H? Okay, later we will discuss. There's a three approach or 3 way to model or estimate H, which is 1 to observation, and then second to experimentation, and the last one is using the mathematical modeling. Okay, from these 3, this later you will see that the first one is more subjective, okay, as compared to the if you what it if you later you realize that from 1 to 3 you can see that number 3 is the easiest one because they are using the mathematical modeling, okay, but the first one is a little bit very hard to perform because of the subjective mechanism on that thing, okay, we will see later, okay, but just remember that this is the three approach that you can use to model the H, which is through observation, okay, and second experimentation, and the third one mathematical modeling.